it's a pleasure to introduce Silvie, who is a well-known person in the decision management community. And while usually she shares her deep knowledge about artificial intelligence, compliance, software development in general, recently Silvie became a chief technology officer of a Dutch startup that delivers a SaaS platform for the transportation industry. So today, Silvie will share with us her practical experience with the development of specific rule-based low-code applications, and she has a lot to share. So looking forward to your presentation.
Yes, thank you very much, Jacob. I thought my topic, I'm a little bit off topic in this conference, but the word low code has already been mentioned this morning by Dennis Gagné. So it's not entirely, and I hope you appreciate it. What I actually will discuss today is some of the darker sides of making software. What makes it really difficult and what are the issues? I will share my experiences in dealing with them as a fresh CTO, as Jacob already mentioned, of the, I will call it a scale up or early scale up that offers a software as a service solution to the transport sector. And one of the solutions to issues in making software may be to involve rule engines, decision support systems, and also low code. However, that is not so easy either. So what I will explain about that, and I will close this session with some practical advice to vendors in this industry. I'm not sure if there are any, I think so. And well, seeing the bright side is important because making changes takes effort, patience, and also the ability to continue looking at the issues from different perspectives. And well, the title is a little bit misleading. Actually, it is on the why we selected the low-code technology for the project named Last Mile. And let me go to the next slide. I was inspired by a book named Making Software. You can Google it now. And it contains scientific research about this topic. It's not really only about issues and solutions, but mainly on how to scientifically research the issues we face day to day in making software, and also how to prove that solutions such as perhaps low code or solutions such as perhaps an agile way of working really work. So the book is about how to do this research. With experience, however, and I think many of us have these experiences, so not scientifically proven, you get to kind of similar results. And I'm sure anyone involved in making software will recognize at least some of these common issues listed here that I have experienced. And one of the things is that there are huge differences between the performance of software coders. And that if you are in a project, you have already made technology choices, and it's very likely that there is some kind of vendor lock-in that at some point in time works against you. It's the not invented here syndrome can very often be found in software teams, and also reuse of code remains very, very difficult. Sometimes you have situations where we say the specifications are not good, there is no testing, no documentation. Then if you want to work on that, there is no capacity, there's no performance management system, etc., etc., etc. So I was wondering for this audience, and also to check whether there is a really an active audience, are you involved in software making? And could some of you use the reactions and let me know with your thumbs up if you are involved in software making? Then I have a little bit of an understanding of the audience that we'll have here. And I see Sandy, and she's saying yes. Denzel is saying yes. And I hope some other will some others will join, but perhaps there are also people that say, no, I'm not involved in software making. I am involved as an analyst in decisions, and that's actually also my background. I will skip the next one and directly go to, so thank you very much for your answers, by the way, to back to this book named Making Software, because some of these issues are actually rooted in factual data research, and resulting in statistics about its severity. So now we're not talking about intuition or experience, but real research that show the severity of these issues. And I go into 3 of these issues in a little bit more detail. And one is what I already said, the huge performance differences between coders, resulting in wrong estimates. So one coder is thinking, I can do this in 1 hour, and another coder needs to do this, solve the same issue in, let's say, 3 days. And these are huge differences, and that make planning in software industry extremely difficult. And how did they research this? Well, this topic, there is a problem called the rainfall problem, and you see here to write a relative easy program. And they gave this problem to 3 classes of students, one doing the first introductory coursing to computer science, and this is actually where you get introduction to loop concepts. And only 14% of the students are able to well, to solve the problem correctly after finishing this course. And then in the second computer science course, you typically learn things such as data structures. It's usually the second semester. And then the bar raises to 36%. And then in the third semester, so the senior, more advanced programming course, students get to 69%. But that means that 30% of the most advanced students could not solve the problem. And these people will become a programmer in the end. So, and also if you research teams, you see that team productivity varies by a factor 10. And that is really very bad for making detailed plannings. The next one is about specifications, which are not complete or wrong. This topic has been researched in several different ways. In this specific research, there was a questionnaire about modification requests, and they asked what fault category of the is the modification request for, and also when was the fault established. And then what you see here the different fault categories. When they get this question, they say, well, the 5% says the problem was into requirements. Now, you think 5%, that's not that much. But the issue is that they had to fix it in a timeline from 1 to 6 after they were halfway. And that really is the trouble, because if you need to fix it so late in the process, you will have delays. And also note that 30% of the modification requests were duplicates, so it doesn't count add up to 100%. And well, if you would correct for them, all percentages would be higher. Now, what turned out to be the cause after fixing it, because this is an estimate of the fault category, but then you're going to fix it, or you're going to make the modification, and the question was asked, what was the real cause? And then you see that more than 55% was related to no good specifications. And you see the details there in the small letters on what kind of causes there were. It's not only an intuition or experience, but it's really researched that we have these issues. And another thing is, and that is about the way people work. And we all know that sometimes you have a dream team, a team that really works very, very well. And how did they measure whether organizational structure and team structure affects the quality of the software outcome? They did a statistical analysis of the code changes and the code in the Microsoft Vista team. And they knew the team structure and who did what. And then they had some metrics like, well, the code complexity, the dependencies between modules in the code, and also organization structure. And they tried to predict from these metrics the number of defects in the software. And actually, as you can see here, all of them are quite good predictors, and but the best one is organizational structure. And what they saw, that more people touching code lowers the quality, losing team members lowers the quality, and cohesive contributors increases quality. And which means that, and that's also what we experienced, that Scrum teams could contribute to a great performance when they are small, stable, and feature oriented. And this is actually also what we experience in practice. Now, also they did some research into proven solutions, and they said that declarative statements such as constraints and event rules are more natural to people to understand, so they are better understood. And actually, as a decision community in declarative rules, I think we all know this, so that's good. Also, they conclude that visual languages are comprehended more slowly than textual languages. That goes a little bit against things like the flows to visualize logic that we see in low-code systems. So I'm very curious if you would redo this research with specific audiences in mind, you would get different kind of results. Also very well proven is that design patterns really help to improve quality and productivity. And I think with using rule engines and low code, you are doing that in some ways. And then two other things, not really related to this community, but very well known. Pair programming really helps to reduce risks and increase quality. And as I said, organizational excellence, a good team, a good environment also really helps. Now, let me say a little bit about myself. As a fresh CTO, I have to deal with all these issues, and adding new people to the team does not really help directly to boost performance because, well, how do I get these people in the first place? Given the market for labor. And then also to get new people in the team up and running, well, we need about 6 months to 12 months before they are really productive. And they take away capacity from the productive people because they need to be guided. So what should I do? Well, of course, I use my experience as a software programmer myself, but well, I cannot sit next to 30 people. So I need to find a better strategy. And about my experience, here is one of my website. I studied artificial intelligence. And let me see if I can scroll down here. No, it's not possible. No, wanted to go back. Can scroll here. Yeah, I can scroll here. So I had my own company, Liberty, that was targeted to help organizations making systems using reusable components and rule engines. And later I founded Rule Arts with Ron Ross to help get more involvement from the business in defining rules and creating adaptable systems. Right now, I see myself more as a all-round entrepreneur for software design processes with a special focus on adaptable software and AI. And I also wrote a book actually about explainability. I think I presented this 2 years ago here in this conference. And I was very happy to see that the researchers of IBM are taking advantage of these kind of new developments. So let me see, how do we get to the next slide now? This is interesting. It's very slow. I integrated a component, and it's not working in all situations. But now here we are to the next slide. This the DecisionCAMP company, I think it's going from a startup to a scale up. Well, I think we are a scale up now, but it has some growing pains. And here are some examples. So when you are a startup, typically you have a few procedures. You have leaders that are hands-on and deeply involved. There's not that much delegation. And but then you become a scale up and everything is a priority. There's unclear communication, and that results in some leadership that is frustrated. So you want to have more delegation. And now you see that we have an organizational structure where you have a management team with a CEO and a CFO and a CIO, and that's the one I am, and the different teams. And the idea is that we really start working as an I wouldn't say like a machine, but really working like a well-oiled machine that produces new features and software for our clients, make them very happy. Now, what are we making them very happy with? This is about next slide. Yes. The platform that we offer. So what we really do is share real-time data about transport, logistics with all the stakeholders in the supply chain. So this way we support collaboration between a shipper and the carrier, and also the location where goods need to be dropped. It is offered as a service in the cloud, and clients pay actually per delivery in what we call a trip. So a trip is one round rounding with a truck to different locations. Initial clients were supermarkets in the Netherlands, but actually that market is kind of saturated. So now we continue with their carriers and other European countries, and also other time critical transport operations. If you go to the website, you will see some more information. And did I share my screen with the option to show video? Sandy, could you let me know when the video is not playing for you?
I'm not seeing. Oh, there we go. It looks like video is playing. It's just loading. Okay. We don't get any audio from the video though.
Yes, sorry, I will reshare with the right options on. Sorry for this hiccup. Yeah.
that's working.
The DecisionCAMP platform requires a planning. This can be a simple CSV file, but we support some of the most advanced planning systems on the market. As soon as a planning is available on the platform, it automatically starts calculating the quickest route from stop to stop and links trips to a specific vehicle and driver. When a truck or home delivery vehicle departs, DecisionCAMP provides the best vehicle-specific ETA predictions currently available on the market. This ensures the planner that the delivery windows actually correspond to the estimated time of arrival. The advanced platform combines smart algorithms from the planning system and enriches them with its own intelligence, such as estimated travel times based on data such as average speed on the road, delays due to bridge openings, and even seasonal factors such as snowfall or extremely busy traffic periods such as Christmas. The platform not only takes into account the best possible route to take and monitors the route.
So I thought 1 minute is enough to get a kind of a feeling of what we do. And if you want to know more about it, then of course you can go to the website. Now, as a software producer, because that is what we do for the transport sector, of course, I want this efficient feature delivery process. And well, there are some things that we need to work on. For example, decrease technical depth, increase the quality of specifications and designs, and minimize the focus shift for programmers. So how we are organized. And then that's where I was working on. And then came a completely new project. And this was named the Last Mile project. And it's all about, and I hope you see the slides now, the web page. If you go to lastmile.info, you can see it for yourself. It's all about just sharing information about the restrictions that you have in a city to get to this specific location. And what you see in cities in Europe is that governments are more and more posing environmental restrictions on these roads. So, for example, indicating which vehicle types are allowed in which streets during which times. And actually, we need to have that information to guide the truck in the right way and also estimate the right destination time. So the issue is that this was a new project, and while I didn't have any capacity to work on it because the backlog is full. The teams are technology oriented, but I would need all these teams to make a website, to share that information and gather feedback. And adding capacity takes too long. I already explained that. And then I thought, can we do it in a different way? And let's look at low code, because, well, what do we need to do with this project? We just need to share information about the restrictions and then collect the feedback. It's no real-time data. There's no high precision algorithms, and the objective of the project is just to increase the quality of that information that, well, the DecisionCAMP platform in the end also needs to process. So this was the idea. And now why do I present it here? Because actually I do believe that decision support systems and low code have a little bit in common. And I was wondering, if I say low code, do you actually know what I mean? So I'm now raising a poll, launching a poll, and you can say, yes, I am familiar with low code. No, I'm not familiar with low code. Or you can say just a little bit. And I see answers coming in. Thank you very much. So I have now a quarter of the people that responded. We get more respondents. And I think, yes, most people are familiar with low code and some are a little bit, and a few are not familiar. So that's good. I'm going to end the poll now. Thank you very much for your answers. I can share the results also with you. And so, yeah, I see some similarities between decision support systems and low code, because what we actually have in common is that we both target the business, so it's business oriented, and we try to involve business people also in making a software solution. And generally, there is a more visual way to represent code. So, for example, in flow diagrams, decision trees, decision tables, and all these kind of things, instead of just the text that a coder is looking at. They are also a little bit different, and well, actually, that was also a disappointment for me. The low-code platforms, most of them have very bad support for business logic, and of course, that is the advantage of rule engines. That is their specialty. And then benefits of both of them, I think, are time to market, because the whole idea is that you get faster into your solutions, and you can also test them easier and involve the business people. I think a rule engine is also more and more marketed and framed as a low-code solution. So if low-code is the new buzzword, then that really makes sense to me. Now, some experiences of the introduction of low-code at DecisionCAMP, and let me go through them one by one. And I think most of these things may also apply to rule engines. And actually, I will also introduce a rule engine, because we also need to represent some business logic. And my experience is that it is even more unknown than low-code suites. So my IT department, if I would do the same questionnaire, have done the same questionnaire 1 year ago, then 90% would say that they don't know about low code or no code. So it's very much unknown. When you explain about it, do you see it has a bad reputation, because immediately they will say it has a bad performance, we shouldn't do it, and it's very limited, so it's not at all useful for us. Then of course I have an IT department with coders, so but the conclusion is coders don't do no code, they want to code, and so they don't do no code or low code. Then also in the budgets, there's actually an inverse incentive, because I have a budget for people, but no budget for tools. And in this specific project, it was even worse. It was a subsidy from the European Union, and we get we get subsidized for making hours and not for buying tools. So if I do the work with less people in less hours, then actually that's not good for the funding. So there's something, very inverse here. And then, well, if you explain about it, etc., and you get the budget finally, then they say, but I do want you to evaluate it and measure your success and report about it in half a year. And but it's very difficult, actually, if you think about it, to measure success, because you also need to train people. And in the end, you could have done it with high code as well, of course, and definitely if you would have had a dream team. So how do you prove it? And then there's the risk of vendor lock-in, which is really which is an issue. And you can say, okay, then I do it again with another vendor, because it doesn't take so much time. But I will say a little bit about pricing when I give my advice to the industry. So, well, the outcome of the low-code vendor selection process that I took, I interviewed about 15 different vendors, I think, is that the market is very fragmented. There are many small parties that, well, yeah, and that are also local players. So there are many players only active in the Netherlands, and also players that are only active in the UK. And they do a good job in these segments, but well, the question is, of course, will they survive in the long run? There are huge price differences. And as I already said, there is no good support for business logic. This is the best you can get to represent your business logic. It's called a microflow or nanoflow in Bendix. And well, if you compare this to a decision tree or a decision table, it's really, well, terrible. And this is just very, very simple business logic. Imagine if you can make it a little bit more complex, what you'll have to manage. What were the deciding factors in the end? It was price. Price was a major factor. It was also training options. So the ability to do trading online, the time needed for people to train themselves in using it, and I think, yeah, completeness of the solution. So there are some low-code platforms that are very, very complete. They even include good ways to represent business logic, including DMN, but they were too expensive for my budget. But the one we have chosen was very complete in things like components to do SSO integration, including a map in the user interface, doing things with, yeah, so really speed up the things we needed to do, scanning a barcode, those kind of things. They were all components that we could use out of the box with no extra price components. So that's good. So that really contributed in making the selection. Then where are we now? So what we have done the selection phase with, as I said, interviews. Then we did a proof of concept with 2 vendors. And based on the results of the proof of concept, which was a case that they had to implement together with us in 2 days, we selected a provider, and then we started with the training. And now we are, well, giving our first demonstration internally and externally this week and next week. So we are just 2 months on our way. What's the idea? The idea is to continue this way, create the user interface, process all the information with the low-code platform until January, February, and then introduce a rule engine, which will be another platform that we have to integrate with the local platform to do the business logic, because for me it was, I don't think it's a good idea to do that in the microflows. And I want really the business to be able to maintain decision tables and let the logic grow over time. What is this logic about? The logic is to establish the quality of the restrictions. So, for example, if a restriction is always violated or never used, then we will lower the quality. And also we will get a feedback from the users. And if they say the restriction is in the system, but actually not on the road, we will also lower the quality. So it will be kind of like a rating system for road restrictions. Then I come to my advice to the vendors. Yeah, I have 5 of them here. I think framing your product in making software, like I do today, is actually not a very good idea. Because making software has all these issues that I mentioned. And also because making software is done by coders, and coders don't like no code. So in that area, it has a very negative connotation. I think it's really should be framed about very quickly do things for the business, like you do in Excel, like you do with a PowerPoint presentation. So really frame it as a business tool. On the other hand, I do believe that more people should be aware of these concepts. And we can start with that also much earlier. So at college, but perhaps also at middle school. People also learn about Microsoft Excel. They do great things with that. And Microsoft PowerPoint. Why not make your own small application? And I think some schools are already heading into that direction, but high code is still the prevalent way there. Then you need to show and prove that it really works. So as an industry, it would be very helpful for me if we have benchmarks. I'm in the lucky situation now that some of the things, some very small things that we're going to do in the low-code platform, we will also do them with high code, with the traditional high code team. So then I can compare the performance of the two ways of working. But this is so important that we have scientific research on whether it works, yes or no. Then I want to say something about price. So my organization has a software as a service platform, and our clients pay us by their delivery stop. So, which means actually that every time they earn money, they have to give us a little bit of that, like a tiny little bit. And that's a very attractive model for our clients, because they don't have any upfront investments, and they can start right away. But with a tool like this, I do have a huge upfront investment because I need to train people, and I need to convince people, and all those kind of things. And once you have built a system and it's kind of stable, you don't have the benefit of the platform anymore. So if I have to pay a high amount for every user continuously, and I calculate what it costs me in 10 years, I get to very high numbers. And that makes the business case difficult. And also you don't know whether this vendor will raise the cost, yes or no. So a SaaS license model, I don't think it has been very beneficial for making my business case, and I'm really wondering whether it's the best model, especially in the long run. Because if I stop paying the SaaS, I immediately don't have any access anymore to the application that has been created, and that is a huge drawback. And that's a benefit of a high code, of course, where you can still run and compile the system after 10 years in most cases. Then I advise the vendors to standardize the terminology. So if you look at the different vendors, then you see that the one is talking about containers, the other is talking about modules, the one has nano flows, the other has workflows, and perhaps they have decisions, but in any of these platforms, the meaning is a little bit different. Also, the way and the different ways you can specify business logic in the user interface, in the data model, in the workflows, That's really very confusing, and it also, as a result of that, if people learn one low-code platform, they cannot easily switch to another one. And so you have a fragmentation of knowledge in the industry. The decision community already started with standardization, and that is really very, very good. And I advise the low-code industry to do the same. Now, I'm not sure if the name low-code and no-code is here to stay. As I said, I prefer to frame the idea in the not in the world of coding, but in the world of business solutions. We used to talk about fourth generation languages, even worse, because it's a language. We also used to name these things case tools. Well, better. But whatever the name, I'm sure it will stay and be improved, because actually making software without using low code is like a painting without a sander, cooking without a blender, autonomous driving without a cruise control, presenting without a microphone, dusting without a vacuum cleaner, making espresso without a boiler, etc., 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 etc. And so, yeah, and I shouldn't be gender biased, of course, but mowing grass without scissors, etc. I hope you appreciated my talk. And let's go to the last slide. Hey, are we still there? Sometimes I have trouble. Oh, was there? Yeah, here we go. Thank you very much. Let's see if there are additional questions. No applause because this is online, but thumbs up if you thought it was relevant for you. And of course, you can connect to me or follow my experiences on LinkedIn. So let's go to the questions, Sandy.
Thanks, Silvie. It's that was really interesting. Just as an old coder myself, it's and somebody who's run a lot of development teams, it's a very interesting point. We were having a bit of a discussion online about low code and graphical and what developers will use and they won't use. I did see a point from Bruce, who said that he disagreed that low code can't do business logic. So you had on one of your slides that there was no good support for business logic in low code, and he said, what if you can have low code business logic and a decision engine in a single tool? Now, I think he's going to be talking about some of this tomorrow, but do you have any other thoughts on just business logic and low code tools?
There were two that had a good way to support business logic in their tool. But as I said, one of them was really too expensive, and the other one, I don't remember, there was another disadvantage, so I couldn't use it. But that was out of 15. And then I know that the 15 is also just a small number of all the low-code vendors that are there. So I think more of them should pay more attention to the way they integrate business logic in their tools. In the end, you get the job done. So we have chosen for Mendix now. And yes, we can specify business logic, but it's not in the way I believe is really good for maintaining it in the long run and good for maintaining it by a business user. So what I will do indeed, I will use another tool, a low-code rule engine, and then integrate the two. But of course, it would be great if it comes out of the box together.
So Silvie, what I see is really kind of the market's a little bit divided in the low code market. Is we have the low code vendors like Mendix who started out as a low code vendor, and they don't necessarily have the sense of some of the standards-based model-driven development. And then you have vendors that come from the BPM systems and the decision management systems who are standards-based, and which is really, it's graphical, but it's code. It's not, you're not going to have most business users doing very complex diagrams in either of those. And they're meeting in the middle with what are both called low code program or platforms, but they have very different heritages and very different sort of capabilities, I think, especially as we look at the support for business logic.
Yeah. So that's why I'm gonna combine two tools.
Yes, I think that you need to, or look at the tools that are coming from the BPM and decision management vendors that have that kind of baked into their DNA.
Yeah, I looked at those too. But then the support for the user interface was we had to create our own user interface, and that was the advantage of a tool like Mendix.
Yeah.
And that responsiveness of the user interface is all very well done. And
yeah, it's a challenge because nobody does it all really well. Is you're going to get the platform vendors who say, oh no, you just get everything out of the box with us. But in reality, you get a lot that's quite good, and then you'll get a couple of things that are really not that good. And you need to make sure that the platforms are not a walled garden that you can put in your own. Like if you need your own rules engine, you can plug that in. If you need your own process engine, if you need your own user experience, that you can plug all of those things in.
Yeah. There's a good question from Carol N.
Yes, I was just looking at that one about benchmarks. It's like, what are you talking about? Runtime performance benchmarks, or are you talking about benchmarks like developer coding benchmarks?
Thank you very much, Anne. Well, I think runtime performance is not that much of an issue anymore because we have instances and we can just add instances. So it's much more about team performance. They claim, and I think this really can be true, that low code, and there's some research into this, is 25% of the effort of high code for the same solution. Well, if I look at the research, then it's just, one team on one solution. And I think that research should be done much more thoroughly.
I found the point that you had about the research that showed that visual languages were comprehended more slowly than textual languages was really interesting, because that a little bit flies in the face of what we kind of think of as common sense, like, oh no, if you draw a picture, people will understand it. Although I think that a lot of the model-driven development, the graphical development, is much more for business communications, or is as much for business communications as it is for programmer productivity. Obviously, there's some exceptions to that. Like you're building your user interface, you're going to do that graphically, but
that's why I said, you need to redo that research with different kind of audiences. Different objectives, but those kind of research, that's really interesting. And then also for a low code, create specific tasks like presenting information, doing business logic, and then test the different tools on those benchmarks. Like you have then you can really compare things. But it's difficult.
But I think as we get pushed down more the path of low code to allow people who don't have maybe the same developer background as some of us do to participate in development efforts, is then are you still going to use the same tools for developers, or are you going to have different tools that maybe share some things in the back end, like the business logic and the models? So then you get into, when do you use one tool versus another, or can you really have one tool that works for everything?
Yeah, one tool that works for everything is definitely not needed, and I think definitely for a company such as Simacan, high code will always be there. Because doing all these navigation things, you can't do that with low code. So it will always be a combination for these kind of situations.
Okay, that's very, very interesting. It's just like just because, like I said, I've spent a lot of time both doing development myself and running development teams, and what we've seen with low code over the years, as things come in, more model-driven development and then moving towards low code, has been, at what point did the developers say, no, I just want to do it the old way? And is that just the old developer saying that, or is that any sort of fully trained technical developer.
Yeah, I definitely like to share the results of this process next year.
Yes, I'll be interested to see that for sure. Okay, I don't see any other questions in there, although there's quite a bit of discussion going on, so you might want to pop over and see the discussion. So what we're